Now we're going to talk about the concept of encapsulation and what that means in our Unity prototypes. So you may have heard of the term scope before, but the concept of encapsulation is just exposing what other things need to know and hiding things that they don't need to know. And we're going to utilize scope in order to do this. If you have a variable that's outside of the scope of a method, then we would call that a member variable. And that means that we can utilize this variable inside of any of our methods. Its scope is within anything inside of the class, which means that if we try to call this variable inside of any one of our methods, that we can do that. It's fine because it's exposed to all of our methods. However, we can also make a local variable, which means that we have declared a new variable inside of a method. If we do that, we cannot access it from other methods by default. In this case, we have int damage, and we've created that inside of start. We try to access it inside of update. We can't really do this because it is not within scope of where we declared it. So just be aware of that, the difference between a class-wide variable and a local variable. And I would say it's actually good practice to utilize local variables, even though they seem more limited. You don't really want your update to know about things that it shouldn't know about or it doesn't need to care about. So this allows us to isolate things to where it makes sense and not clutter information wherever it does not make sense. So encapsulation is when we can start to determine what is private and what is public and protected according to whether or not other things should see it and if it makes sense for other things to see it. So just to show you the big ones that you're going to use a lot, I have these listed over here. Main one is private, public, and serialized field. Protected, you may not use until later on once you start doing inheritance. If it's not labeled, assume that it's private and nothing else can see it. And the only things that can access it are inside of the class, if it is class-wide, a member variable. If you put private, you're just explicitly saying, okay, nothing outside of this class can see it, only things inside of this class. If you put public, this means two things inside of Unity. One, it means that it's going to expose it to the inspector and serialize field it. And it's also going to be visible to other scripts. So if another script says player stats dot lives, it will be able to see this, whereas it will not be able to see the money or the experience or whatever, because those are private. If another class tries to look at health, it will actually not be able to see that because it is private. But because we did serialized field, we can still access it inside of the inspector. So kind of a subtle difference between public and private, but very, very important. If you just want to expose it to the inspector, use serialized field. Don't use public unless you want other things to see it. And lastly, protected just means that if you inherit from this class, then you will be able to see it, but other classes cannot see it. So it's a little bit weirder and you're not going to mess with that quite yet. But these are the big ones to know about up front. And lastly, we can do a very similar thing with methods where we can say private methods. Nothing outside of the class can see this, so we can still call it inside of health. But if another object like enemy tried to look at the health of this thing, it would not be able to do knockback or kill, for example. It can only see public methods. So just remember that. Once we start getting into objects referencing each other, like you want the player to see something on the enemy or the enemy to see something on the whatever, then you need to make sure that you consider what is public and what is private and what you are exposing. Now let's look at a few examples inside of Unity and how we can utilize public and private methods inside of our class referencing. So first of all, I'm going to create a level controller just to have something that can manipulate things in our level. So I'm going to create empty and call this level controller. And we're also going to create a script called level controller. And finally, make sure that you apply that script to level controller. Zero it out. This should hopefully become second nature to you at some point. Let's say that we have a player inventory or something that we want to be able to look at, and maybe our level controller can manipulate an inventory in some way. So let's create a new game object, create empty. We'll call this inventory. We'll make a new script for this called inventory, just again, keeping things very simple for now. And let's consider what we want to do. Let's still apply our inventory onto our inventory game object. Again, zero it out. Let's go into our level controller. First thing let's do is let's just access the inventory. And remember to reference a instance of something in our scene. In this case, we want our instance of our inventory component in our scene. We're going to expose that so that we can drag and drop it in the inspector. And we need to create the variable of type inventory because we want to store it so that we can manipulate it. Inventory. A lot of times I like to assign defaults when I expose them in the inspector just so I know for sure what it's going to be. So a lot of times if it's a custom class, I'll just say equals null. It's preference. And then what we want to do is we want to start accessing the inventory when we do button presses. So let's consider something we can do. We can say if input.getKeyDown, key code, let's do Q. One thing you can do if you do // and you type capital to do, there's a special way that you can search to do comments inside of Visual Studio. So you can actually leave little things for yourself so that you can mark this at a place you can come back to. Kind of a fun little tip. Add money to inventory, create another if input.getKeyDown, key code dot, let's do W. And in this one to do, print the current amount of money. I'll just get rid of this comment up here just to save some space. Okay, so we have our framework. Now let's go into our inventory and actually fill this out. So we want to add money to the inventory and we want to have some way to access the current amount of money. I'm going to open up my inventory script and let's consider what we want. Now I could start to type in int money is equal to, and then we can give a default money amount. But remember that over here in level controller, we decided that we want to be able to print the current amount of money, right? So inside of inventory, we may want to consider if we make this public. Now, if I were to make this, if I were to do serialized field, what this would do is this would allow me to click on inventory and see the amount of money and maybe change the starting value, but we still can't really see it. So if I were to go to W and say debug.log current money append and say inventory dot, we're not seeing money come up. So what I want to do here is I'm going to comment this out so that it'll compile. Come back over to inventory. I'm going to make this public. So instead of serialized field, it's public. Public int money. And good practice is if you make something public to also capitalize it. It's just standard Microsoft convention. So I'm going to recommend I just right-click rename. Easier to catch every instance of it. Just rename it to money with a capital M. So capitalized for public, and I'm going to come back into level controller. Now, if we uncomment this, debug.log, if we come back here, inventory dot, you see we can see it now because it is public. So if we were to add a semicolon right here, make sure that we can compile. If I come back into play mode and I hit play, and I click down here, if I press W, you'll see we get a null reference. And consider for a second why. Now the reason is because if we exit play mode, click on level controller, we never assigned this instance of the inventory. We could have multiple inventories in our scene. We want to know which one. So we're going to say, okay, this one right here, save. And just to make this even more clear, maybe this is the player object, right? Maybe the player also happens to have inventory. It can also have health. It could also have other things. And maybe this is another way to think about it for you. So let's do that. We'll make this the player game object, and the player game object has inventory. So level controller, we just make sure, we drag and drop that in. So you can see it's accessing the inventory on the player game object. So let's go back and hit play mode now. Look down on the game view. If you hit W, you can see it's printing the current amount of money. And we can do this because our level controller can see the money on our inventory because we made our inventory money variable public. So let's see what else we can do. We mentioned that we want to add money. Let's make a new method here. Well, we'll call this increase money, I think. And let's also give this a parameter. Let's modularize this a little bit. We'll say int amount. So how much money, if we pass it an integer, how much money do we want to increase this by? And so we can take our money, and to add our amount to our money, we just say money is equal to money plus amount. We could do that. Or remember the shorthand is we could just say plus equals amount. So money plus equals amount takes the current money and adds on top of it an amount that we pass in. Come back to level controller, and we already have access to our inventory, and we added this public function here. So we could say inventory dot increase money, give it an amount. Doesn't matter here. We'll give it 15. Just pick up a little gold or something. Okay, save it. And so if we press Q, we are increasing the amount of money. And if we press W, we are viewing from another object. We're looking at this public money and looking at the current amount, right? And it's increasing here. So let's save it, come down. And so this is what public variables allow us to do. If I hit play, click down here inside the game window. If I print the amount with W, so we can see 100, press Q a couple times, and then press W again, you can see it's at 235. You could press it, print it again, press it, print it again. We can increase the amount, and then we can print it off. So just so you can see the difference between private and public, you may want some private methods inside of your inventory as well. So let's say, for example, what if you needed some kind of inventory slots? So we'll say serialized field. In this case, we'll access it from the inspector, but let's say number of slots. We'll say num of slots is equal to 4. So let's say our inventory has 4 slots. We're not really doing anything meaningful with it, but let's save this, go back into the inspector. So we can assign a number of slots. Now, just to leave a placeholder, if we did have logic here, let's say that we need to set up these slots inside of start. We wouldn't really want other objects to be able to see how we're setting up our slots. They don't care about that. Only the inventory cares about how it's setting up slots, right? So this might be a place where you don't want to make something public. So we'll do void load into slots, like maybe you're loading in the previous inventory weapons or something. And then let's print a statement for every slot we have. Now, if you remember, we talked about loops previously. Consider how you can do this inside of a loop. I want to print a statement for each slot that I have. So I'm going to use a for loop here. I'm going to type for, tab twice to just autofill this in, or you could type it in, good practice. And then I want to repeat this loop for the number of slots. So I'm just going to copy paste that. So it should be 4 times. And for each slot, we're going to just print a statement. And then I'll just also print the slot index here, append I. And remember that it is printing that integer as a string. So this should be some good review for you. For each number of our slots, we're just going to print. And we could add pseudocode there later for whatever loading and saving is going to be. And then finally, we'll just call this private function inside of start. So yeah, we have our public method here where we want other things to be able to access it. But also remember, you don't have to make everything public. We may have some things that we don't want other classes to see because they don't care about them. So why show it to them? Let's test this out really quick. Control S to save. Jump back out. Hit play. Load slot index 0, 1, 2, 3. So for each of our slots, it's loading it in. And our level controller does not even know about it, which is good. And again, we still have our Q, our W, WQ, W to test that out. So hopefully this gets you to start thinking about defining what you want to be public and what you want to be private. We could actually put private here instead of nothing, but again, nothing will assume private. Keep this in mind. You don't want to expose everything, and if you do want to put something inside of the inspector, use serialized field. Don't use public. You don't really need it yet. And I would say good practice is to start private. Start with not even serialized field. If at some point you discover, oh, I may want the designer to access it, open it up a little bit. Same with money. Maybe you don't start off public, you just start private. And then if at some point you realize you need to open it up a little bit, you can open it up one step at a time. Maybe you do serialized field. And then if you need more access than that, then you go public, or maybe you go protected, or there's a lot of other ways to expose things. But for now, just think about public, private, and serialized field and how you can use those with strategic intent as you are writing your code.